In the vast cosmic tapestry of existence, where galaxies dance and nebulae shimmer, a breathtaking spectacle unfolds. A symphony of celestial birth and death that holds the keys to unlocking the secrets of our universe. Join us on an awe-inspiring odyssey as we delve into the heart of stars, witnessing their majestic creation and cataclysmic demise. Brace yourself for a cosmic journey like no other, where ancient stardust whispers its secrets, and the mysteries of the universe are unveiled before our very eyes. Stars do not live forever, just like people. Stars are born, live their lives, changing or evolving as they age, and eventually, they die. Often stars do this in a much more spectacular way than humans do. Scientists speak of stellar evolution when talking about the birth, life, and death of stars. The lifetime of individual stars is way too long for humans to observe the evolution of a single star. So how do scientists study stellar evolution? This is possible as there are so many stars in our galaxy, so we can see lots of them at different stages of their lives. In this way, astronomers can build up an overall picture of the process of stellar evolution. In this video, you will know how stars are born, how they evolve, and how they die. The birth of a star. Stars are born in vast, slowly rotating clouds of cold gas and dust called nebula, singular nebula. These large clouds are enormous. They have masses somewhere between 100,000 and 2 million times the mass of the Sun, and their diameters range from 50 to 300 light-years across. A famous example of one of these huge clouds is the Orion Nebula in the constellation of Orion. It is visible to the naked eye if the sky is dark enough. These clouds are so massive that they can collapse under their gravity if they are disturbed. Over time, the clouds contract, become denser, and slowly heat up. The clouds also break up into smaller clumps. As the clumps get smaller, they begin to flatten out into a disc shape. The center of each clump will eventually contain a star, and the outer disk of gas and dust may eventually form planets around the star. As the contracting clump continues to heat up, a protostar is formed at the center. A protostar is a dense ball of gas that is not yet hot enough at the center to start nuclear reactions. This stage lasts for roughly 50 million years. As the collapse continues, the mass of the protostar increases, squeezing it further and increasing the temperature. If the protostar is massive enough for the temperature to reach 10 million degrees Celsius, then it becomes hot enough for nuclear reactions to start, and the protostar will technically be referred to as a star. Young stars. The young star starts converting hydrogen to helium via nuclear fusion reactions. Nuclear reactions in stars produce vast amounts of energy in the form of heat and light, which is radiated into space. This energy production prevents the star from contracting further. As the star shines, the disk of dust and gas surrounding the star is slowly blown away by the star's stellar wind, which leaves behind any planets if they have already formed. Life of the star. A star is considered to be born once nuclear fusion reactions begin at its center. Initially, hydrogen is converted to helium deep inside the star. A star that is converting hydrogen to helium is called a main sequence star. Stars spend most of their lives as main sequence stars, converting hydrogen to helium at their centers or cores. A star may remain as a main sequence star for millions or billions of years. Main sequence stars are not all the same. They have different masses when they are born, depending on how much matter is available in the nebula from which they formed. These stars can range from about 1/10 of the mass of the Sun up to 200 times as massive. Different mass stars have different observable properties. Main sequence stars also have different colors, depending on the temperatures of their surfaces. Death of a star. As a star enters the final stages of its life, after it has become a red giant, the star becomes unstable and expands and contracts over and over. This causes the star's outer layers to become detached from the central part of the star, and they gently puff off into space. When the last of the gas in the star's outer layers is blown away, it forms an expanding shell around the core of the star called a planetary nebula. Planetary nebulae glow beautifully as they absorb the energy emitted from the hot central star. They can be found in many different shapes. Sometime after puffing off its outer layers, the central star will run out of fuel. When this happens, the central star begins to die. Gravity causes the star to collapse inwards, and the star becomes incredibly dense and compact, about the size of the Earth. The star has then become a white dwarf star. White dwarfs. White dwarfs have this name because of their small size and because they are so hot that they shine with white hot light. The central parts of stars are much hotter than their surfaces, and a white dwarf is made from the remaining central parts of a star, which explains why they are so hot. White dwarfs no longer produce energy via nuclear reactions, and so they radiate their energy into space in the form of light and heat. They slowly cool down over time. Eventually, once all of their energy is gone, they no longer emit any light. The star is now a dead black dwarf star and will remain like this forever. Supernova. Stars more than 8 times the mass of the Sun end their lives spectacularly. When the hydrogen at their cores becomes depleted, they swell into red supergiants, which are even larger than red giants. A red supergiant can fuse successively heavier and heavier elements for a few million years until its core is filled with iron. At this point, nuclear reactions stop and the star collapses rapidly under its gravity. The collapsing outer layers of the star hit the small central core with such a force that they rebound and send a ripple outward through the star, blowing the outer layers of the star into space in a huge explosion called a supernova. As the celestial symphony draws to a close, we are left in awe of the cosmic ballet that unfolds before our eyes, revealing the mesmerizing secrets of stellar birth and death. From the fiery cradle of star formation to the explosive grand finale of supernova, this extraordinary journey has illuminated the very fabric of our universe. So let us embrace this cosmic dance, forever captivated by the majesty and mystery of the universe. For it is in the birth and death of stars that we find the keys to unlocking the enigmatic secrets that lie beyond our earthly horizons. If you found our video informative, kindly subscribe to our channel so you won't miss out on our videos.